In this video, we'll explore intermediate operations in the Stream API. These operations can be used to modify or filter elements in the stream before the terminal operation is called. Intermediate operations are optional and can be chained together in the stream pipeline. We'll cover some common intermediate operations and demonstrate the usage with practical examples in IntelliJ. Alright, so this time I'm not going to sit you through the typing, but I am going to walk you through all of these examples. I did expand the list a little bit for the sake of these examples. So here we see the filter, and the filter filters the stream based on a predicate. And the predicate that we're having right here is that the name should start with a B. When the predicate is true, the element will stay in the new stream. When it's false, it will be removed. So the name starting with B is only going to be a stream with the element Bobby in it. And then we have map. I find myself using filter and map a lot. Map applies a function to each element in the stream. And as you can see, after this map method, we no longer have a stream of strings, but a stream of integers. And that's going to turn the stream into a stream of integers representing the length of the strings. And again, you'll see that we need to use a method reference here. So I hope at this point you understand why method references and lambda expressions are so important. And then we have flatMap. FlatMap is a function that we can use on all the elements in the stream that's going to flatten the results into one single stream. So on line 20, we have a little bit of a complicated object. We have a list of lists. And on this list of lists, we have two arrays. One holding Bobby and Django, 2 nice dogs I happen to know. One holding Mandarin, Walnut and Snowflake, 3 rabbits. So these two lists means that the first stream that we're going to be creating, the nested stream that's going to be created right there, it's going to have 2 elements of type list string. The first one is the Bobby Django element, and the second element are the rabbits Mandarin, Walnut and Snowflake. So the flat names that we're creating is actually going to turn these into a stream of type string containing 5 elements: Bobby, Django, Mandarin, Walnut and Snowflake. It's flat after this. There's no more hierarchy, there's no other levels, it's just one stream of elements of string. And then we also have peek. Peek is nice for debugging because it's going to perform an action on each element in the stream without modifying the stream. So if, for example, after a filter, you might want to see what's still in the stream, well, you can do this with a peek. And very common is to just print the result of a peek, as we're doing right here on line 24. We can also limit the stream to a certain number of elements, and this can be particularly useful for otherwise infinite streams. In this case, we're just limiting our stream to 3, even though our stream would have a size of 5 originally, so there will be 3 elements left. Then we have skip, and with skip we can skip some elements in the stream. In this case, we're skipping the first 2. So the new stream string is going to not have the first 2 elements, but it will have the last 3. Then we have distinct, which will remove any duplicates if they are present. In our case, this won't do a lot because we don't have duplicates. And lastly, we have the sorted. And sorted, well, it's a bit in the name, but it's going to sort the elements in the string according to a comparator. And in this case, we choose for the natural order. So at this point, we have all the ingredients of a stream pipeline. And with these intermediate operations, we can chain them together. So, for example, we could first do a filter, then do a map, then do a peek, and then end with some terminal operator. And this chaining and ending with the terminal operator is exactly what we're going to do next. We'll demonstrate how to use the Stream API for some practical examples.